Alright, hello. This video is going to focus primarily on memory. Alright, so we want to look at the three processes of memory: encoding, storage, retrieval, and then also the three types of memory: sensory, short-term, long-term. Okay? So with the three processes of memory: encoding, storage, retrieval, the best way to think about this is just how a computer might work when you're working on a file and you need to save it. So the process of actually saving the file for the first time, that's what we call encoding. All right, so this is when we have a piece of information that we have learned and we are trying to commit it to memory. So the process of learning that is it's in being encoded into our memory. Right? So learning and encoding kind of go hand in hand. Once we have learned something, it is then stored. All right, that's the second process of memory. It's stored, and just like a file, we have it saved on the hard drive, and it's there for us to go back, and then whenever we need it, we can open it, and open that file, or like we're talking about memory, we can go and retrieve that memory. Right? So encoding, storage, retrieval. We also have three types of memory. Right? So we have sensory memory, and this is all the information that we collect through our five senses. Right? So as we see things, hear things, taste things, feel things, whatever, as we take that information in, we hold on to it for a very brief amount of time. Right? It's usually 3 seconds or less. Actually, it's like less than a second, less than half a second. The only time we get to 3 seconds is with our hearing. One way you can think about this is that, let's say someone walked up to you and started talking to you before you were ready. So you might look at that person and say, "What did you just say to me?" Like, because you didn't hear them. But in the process of asking them, "What did you just say?" it's almost like we can hear it. Right? We hear it. Because what we're doing is we're accessing that little bit of a trace of the memory that's still left. Right? So hearing gets us to 3 seconds. Everything else is half a second to a second or less. Right? That sensory memory, though, so we're going to collect a lot of it, but hold on to it for a very short period of time. Whatever it is that we focus and pay attention to from all this sensory memory will then make its way into our short-term memory, which is often called our working memory as well. Here, that duration, as far as how long we can hold on to the information for, it gets extended out quite a bit. All right, so we go from a second to 3 seconds, and we're going to expand it out to about 20 or 30 seconds. All right, so this is information that we're actively pulling from our sensations, what's going on and around us in our environment, whatever we're paying attention to. We have that information, and we're going to hold on to it for roughly 20, 30 seconds or so. Anything beyond that, we just tend to lose it, and it fades over time. Right? If you want to keep something in your short-term or working memory beyond that 20 seconds, that is possible. You have to do something called maintenance rehearsal. And basically, it's just repeating it to yourself over and over and over again. And as long as you keep repeating it, you're going to hold on to it. But the second that process is disrupted or stopped in any kind of way, the memory is going to quickly fade. So this is a silly example, but what I always like to think of is you're with some friends, you want to order some pizza, so you have everybody's order. Then you realize your phone is in another room, but the number to the pizza place is right there in front of you. So you read the number and you keep repeating it to yourself over and over and over again as you walk towards your phone. And so as you're walking across the room, one of your friends yells out to you, says, "Hey, don't forget, on my Hawaiian pizza, I want extra pineapple." In that moment, you feel compelled to tell your friend Hawaiian pizza is trash, and adding more pineapple to it doesn't make it any better. Right? And so then you continue, you get to your phone, you pick it up, and at that point, you have forgotten the number because you stopped that process of maintenance rehearsal. Okay? The other thing that we have to keep in mind with our short-term memory is that it has a very limited capacity. It cannot hold that much information. All right? So this makes sense with what we know about our attention. We can only do so much. We're very limited. So George Miller, through his research, he found that the magic number here is 7 plus or minus 2. Right? So we can hold, on average, 7 bits of information. It's a range, though, so plus or minus 2 gets us a range of 5 to 9. So if we're presented with 5 bits of information, very easy for us to do. Everybody can do it. 7, most people are going to do it because, again, that's the average. 9, we're going to lose some people, but that tends to kind of be the upper limit. Anything beyond that, it's very, very difficult for us to do unless we have something available to us called chunking. And this is where we can take information and identify certain patterns or groupings that make it a little bit easier for us to remember. All right, so if you look at a typical phone number, for example, the number of digits goes beyond our normal capacity for short-term memory, but yet we can remember them just fine because it's not all those individual bits, but rather we take those numbers and we break them down into groupings. And so each of those groupings count as an individual bit of information. Okay? Even then, though, we have this idea of cognitive load, right? And so it's how much information you can actually effectively process at any given moment. We reduce that cognitive load through chunking or just practice doing something so it becomes so automatic it requires less effort. Okay? All this is great, but the real goal of learning is trying to get information properly encoded into long-term memory, right? That's where we want information to go. Long-term memory, this is the hard drive of the brain, but this is where we're going to vary and differ a little bit from our example of relating human memory to computers. Because a computer, its hard drive, has a finite amount of space. And once you get to that amount of space, done. You can't add any more unless you delete something. When we look at the human mind, it is virtually limitless in its capacity, right? So as you learn new things, your brain will just make more room, right? It just makes more room for that information to come in. And what we find is that the more you already know, it makes it even easier to learn and know and store more things, right? So pretty much virtually limitless capacity. And when we talk about duration, how long memory is going to stay, once it's there, it's not really going anywhere, right? It's like infinite. Like it's not going anywhere. It's gonna stay. So we want to get information into long-term memory. In order to do that, in order to properly encode something, we can't do that maintenance rehearsal we did before. We can't just repeat something over and over and over again. That's not going to work. We have to engage in something called elaborate rehearsal. So this is taking the information that we're learning and then trying to do something more with it. All right, how can we do this on a deeper level, a deeper understanding? How can we connect it to things that we already know, or things that apply to us, experiences that we've had in life, or how we might be able to use it in something moving forward? The more we can do that, the easier it is to learn and retain that information, right? And so once it's stored there, again, we can go back in the process of retrieval and pull that information into our short-term memory so we can remember everything. With our long-term memory, it has different kind of like sub-levels below that. The two main ones are explicit and implicit. All right, so an explicit memory is something you know it, and you don't have any problems talking about it. Okay. If we compare that to an implicit memory, though, this is something you know it, but you might not be able to quite explain it. All right, so a lot of times this is like procedural memories or muscle memories. So let's say if I asked you, do you know how to type? You're going to say yes. And that means if you know how to type, you know what all the keys are on the keyboard. And so if you were then asked, what are all the keys on the keyboard on the bottom row in the correct order? Well, that becomes a little more difficult for us. Like we know it, we know it, but being able to talk about it is a little more difficult. It's just something that you just do. You just start typing. So you have that information stored. You do know what they are, but it's a little bit harder to explain. Right? That's what I mean by implicit. It's there, we know it's there, but we can't quite talk about it. Right? Explicit memories, you know it, and you can talk about it just fine. With that, though, there are two types of explicit memories. We have semantic and episodic. A semantic memory is this, think of it as the accumulation of all the knowledge that you've acquired over time. So if someone asks you, hey, who was the first president of the United States? You say George Washington, right? That's a semantic memory. It's a piece of information or a fact that you have learned. If we compare that to episodic memory, though, this is memories about our life and our experiences, right? So if someone asked you, hey, what did you do on your last birthday? Any memories that you're retrieving and pulling from your long-term memory to think about that, those are episodic memories. Right, so it's information about you, about your life, and the different experiences that you have had. Okay? So just to recap, we have the 3 processes of memory: encoding, storage, and retrieval, and then also the 3 types of memory: sensory, short-term, long-term.